In 2.4, we're going to learn more about linear equations. We're going to learn how to write the equation of a line given its slope and a point on that line, and how to write the equation of parallel and perpendicular lines. So in the last lesson, we talked about slope-intercept form, y equals mx plus b. Now we have a new form, which is point-slope form, and it says y minus y1 is equal to m the slope times x minus x1. And here, both the y and the x, those are going to stay as variables. But y1 and x1, that is going to be the point that we are given. And our slope of m is the slope of the line. So if we look at our first example, if we want to write an equation given both the slope and the points, we just need to plug them into the proper place in our general formula. So we have a line that passes through negative 5, 2. So negative 5 is x1, and 2 is y1, and then the slope is going to be 3/5. So we're going to have y minus y1, which is 2, equals our slope 3/5 times x minus x1, which was negative 5. And notice how I'm putting both the x and the y values in parentheses when I plug them in. Because when we have this subtraction of a negative number, we need to be careful to remember that we're actually multiplying by a negative, so therefore it's going to change it to be a positive value. So this would become 3/5 times x plus 5, and then we still have y minus 2 over on the left. So we're going to notice that the sign of our points, we start off with a positive 2, well, it changed to be a negative 2 after it got plugged in. And with our x value, it started off as negative 5, but after we plug it in and simplify, it ends up being positive. So the sign of each point is going to change once it gets plugged into the formula. Go ahead and give b a try. Because you're subtracting negative 1, we're going to end up with y plus 1 equals negative 3 times x minus 7. Now, what if we want to write the equation of the line in point-slope form if we're given 2 points? Well, if we're going to do it in point-slope form, we need 2 things. First, we need to know the slope, and second, we need to know a point. We have 2 points, but we don't have the slope. With those 2 points, though, we can find the slope, just like we did in the previous lesson. So first, we need to find that slope. Remember, we have x1 and y1, x2 and y2. So we're going to do 2 minus 8 over 3 minus 5, and that gives us negative 6 over negative 2, which will give us a positive 3. So now we know what our slope is. Now we can plug this into point-slope form. It doesn't matter which point we use. We could actually use both of them. If we're using our first point, we're going to have y minus 2 is equal to 3 times x minus 3. Or if we're using our second point, then we're going to have y minus 8 is equal to 3 times x minus 5. Since it didn't specify which point to use, both of those would be correct answers. We also have what we call the standard form of a line, and this is the last form we're going to look at. And it says that we have ax plus by equals c, where a, b, and c are all just numbers, and a and b cannot both be 0. So if we compare this to some of our other forms that we've had, like y equals mx plus b and y minus y1 equals m times x minus x1, if we compare these 3 forms to each other, do you notice anything about the relationship between where the y variable is positioned and where the x variable is positioned? In both slope-intercept and point-slope form, the x and the y are on opposite sides of the equal sign. But now the x and the y are on the same side of the equal sign when they're in standard form. Now there is one other requirement with standard form. It says that a must be a whole number. So it can't be a fraction and it cannot be a decimal. Let's take a look at our first example. We want to write y equals 3/4 x minus 5 in standard form. Since x and y are on opposite sides, we need to move x to the same side as y. So we're going to subtract 3/4 x to both sides. So we're going to have -3/4 x plus y is equal to -5. Now we're to the point that we have to make x be a whole number. Can't be a fraction. The best way to do this is to look at what's in the denominator of x, and that's what we're going to multiply both sides of our equation by. So if we multiply both sides by 4, that's going to cancel out the 4 that's in the denominator. So we'll have -3x. We also have to distribute that 4 to our y, plus 4y is going to be equal to -20. Pause the video and give B a try. Remember, first you need to move x to the same side, then you need to multiply by whatever will make x become a whole number. In this example, you should be multiplying by 5 in order to cancel out that denominator for the x variable. And after you distribute, you'll get 4x plus 5y equals 10. Just like we have many different equations of a line, we can also graph from each of those equations. So here we have an equation in standard form. If we want to graph this, the easiest way would be to use its intercepts. And when we're talking about intercepts, this is going to be where we cross the x or the y-axis. So the x-intercept is when we're crossing the x-axis, and the y-intercept is where we cross the y-axis. No matter where you are along the x-axis, you're always going to be at the value of 0 for y. So when we're going to find the x-intercept, we need to plug in 0 for our y value. So we'd have 3x plus 5 times 0 equals 15. 3x equals 15. So x is going to be equal to 5. And as a point, this would be 5, 0, because we already said we knew what y was and y was 0. And now we can put that on our graph. Now, if we're going to find the y-intercept, we're just going to do the opposite. We're going to plug in 0 for the x value. So this would be 3 times 0 plus 5y equals 15. So 5y equals 15. And y equals 3. If we put this together as a point, we said the x value is 0 and the y value is 3, and we'll have our coordinate. We can plot that here on our graph. Now that we have 2 points, that's all we need for a line. We can connect each of these points, and there is our graph. So when you have an equation in standard form, if the numbers work out pretty easily, then you can just plug in 0 for both x and y to find the corresponding intercepts. Then just draw a line through both of those points. Go ahead and give this second one a try on your The x-intercept comes out to be 4 and the y-intercept is -2. When connecting those points, you should get a positive slope that rises from left to right. When we compare two lines together, sometimes they'll be parallel and perpendicular to each other. We want to find the slope and the y-intercept of each of the lines below. In the first image for line 1, to find the y-intercept, we're going to see where we cross the y-axis at. So our y-intercept is going to be at -3. Then to find the slope, we need to see where another point is. Let's say we use this one right here, and we're going down to over 1, so slope is -2. For the second line, our y-intercept is up at +2. And the slope looks like we use this x-intercept as well. We're going to be going down 2 and over 1. So the slope is -2. In the second image, we have two perpendicular lines. Again, we can find our y-intercept on our first one, which is going to be at 4. And right here, we appear to cross. So we're going to go down 1, 2, 3, over 1. So our slope is going to be -3. On our second line, we're going to have a y-intercept of 1. And then our slope is going to be up 1 and over 3. So our slope is going to be 1/3. Now pause the video. Looking at the information from our first graph, see if you can notice anything about the y-intercept and the slope and how they relate to each other. Then do the same thing with our second graph. See if you can find any relationships. When comparing our parallel lines, they both have the same slope. In both cases, they had a slope of -2. However, their y-intercepts were both different. If they had the same y-intercept, then they'd be the same line. So with parallel lines, they always have to have different y-intercepts, and they always have to have the same slope. When it comes to our perpendicular lines, they have what we call opposite reciprocal slopes. Opposite in the fact that one was negative and the other one was positive. Reciprocal in the fact that the numerator and the denominator of the fractions flip. We had 3/1, and then we also had 1/3. Then, when it comes to our y-intercept, they were different in this case. However, it is possible to have perpendicular lines that have the same y-intercept. If we do a quick little sketch, this could be what it potentially could look like. Maybe we have this line like that, this one here, and the point where they cross are both on the y-axis, so then they would have the same y-intercept as well, while still having opposite reciprocal slopes. So with perpendicular lines, the slopes always have to be opposite and reciprocal, but the y-intercept could be the same or it could be different. Let's see what the slope of the line that is parallel to the given lines is. What we want to do is identify our slope. So here we have a slope of -1/5. That means the slope of the parallel line is going to be the same, -1/5. If we want to find the slope of the line perpendicular to a given line, again, we need to start by identifying our slope. Then the slope has to become opposite and reciprocal. So opposite, we had +5/2, now it's going to be negative. Reciprocal, we're going to flip. Reciprocal, we're going to flip the fraction around, and it's going to become 2/5. Go ahead and find the parallel slope of this equation and the perpendicular slope to this equation. For our parallel line, the slope would be 3/2. For the perpendicular line, it's going to be 1/4. Remember, change the sign, so negative to positive. Then this is really 4/1, so we flip that fraction around to get 1/4. We're going to use this understanding that we now have of parallel and perpendicular lines to be able to write the equation of a line parallel or perpendicular to a given line. And here's our step to do so. First, we want to make sure that the equation is in slope-intercept form. On our first example, we are given the following equation. Remember, slope-intercept form is y equals mx plus b. So we need to solve for our y variable. To start off step 1, I'm just going to rewrite our equation. So we have -12x plus 2y is equal to -4. We're going to add 12x to both sides in order to cancel that out and get y by itself. So 2y will equal 12x minus 4. Then we can divide both sides by 2, and y is going to equal 6x minus 2. Step number 2, we need to determine what slope to use. Do we need to have the same slope or the opposite reciprocal? Since it has asked us to write the equation of a parallel line, we are going to have the same slope. So our slope was 6, and for our new line, the slope is going to continue to be 6. Step number 3 says now we have a point in which we're going through, and we have the slope. So we're going to plug these into the point-slope form. Remember, point-slope form is y minus y1 equals m times x minus x1. Our slope is given here in step number 2, and then the point is given back from the original question. So we're going to have our x1 and our y1. So we'll have y minus a -3 is equal to our slope of 6 times x minus 1. So that means we're going to really end up with y plus 3 is equal to 6 times x minus 1. Then step number 4 tells us we need to distribute our slope to everything that's in the parentheses. So we'll have y plus 3 still is equal to 6x minus 6. Then step number 5, we are going to go ahead and solve for y. So we just need to subtract the 3 on both sides, making sure to line up our like terms. So y will be equal to 6x minus 9. This is the equation of the line that is parallel to the original equation, and it also goes through that specific point of 1, -3. In the next question, we're going to find the equation of the line that is perpendicular to y equals -4x plus 2/3 that goes to the point 8, 5. We're going to go through all the same steps. First, it needs to be in slope-intercept form, which it already is, right? We had y equals -4x plus 2/3. Step number 2, we need to determine what kind of slope. Since it's perpendicular, we're going to make sure we're using the opposite reciprocal slope to -4. That means opposite is going to be positive. Reciprocal, this is 4/1, so it's going to become 1/4. Step number 3, we need to use our slope as well as the given point to now write the equation in point-slope form. Pause the video and give that a try. You should end up with y minus 5 equals 1/4 times x minus 8. Now we want to solve this equation for y. That's going to mean we need to distribute and then solve for y. Pause the video and try steps 4 and 5 on your own as well. After distributing, you'll get 1/4 x minus 2. Then add 5 to both sides, and y is going to equal 1/4 x plus 3. So this equation is a line that is perpendicular to our original equation, but it also goes to that specific point of 8, 5.